Hello students. You're welcome to today's chemistry lesson. We'll be studying gas laws part 2. But before we continue, let's look at what we studied in our last class. In our previous class, we studied gas laws, focusing on Boyle's law and Charles' law. Boyle's law explains the relationship between pressure and volume when temperature remains constant. A good example is a bicycle pump. When you push down the handle, the air inside is compressed. This reduces the volume and increases the pressure, forcing air into the tire. Charles' law explains the relationship between temperature and volume when pressure remains constant. A common example is a hot air balloon. When the air inside the balloon is heated, its temperature increases. The air expands, becomes less dense, and the balloon rises into the air. Our lesson objectives for today are to explain the general gas equation and learn about Gay-Lussac's law. The general gas equation, also called the combined gas law. Scientists like Robert Boyle and Jacques Charles helped us understand the relationship between pressure, volume, and temperature of a gas when none of them is constant. Now, here is the formula. P1 multiplied by V1 divided by T1 is equal to P2 multiplied by V2 divided by T2. Very important note, temperature must always be in Kelvin. To convert from degrees Celsius to Kelvin, we add 273, where P1 equals initial pressure, V1 equals initial volume, T1 equals initial temperature, P2 equals final pressure, V2 equals final volume, T2 equals final temperature. Now let's understand this in a simple way. If pressure increases while temperature also changes, the volume must adjust accordingly. All three quantities are connected. When one changes, the others respond. Now let's solve an example together. A gas has an initial pressure of 100 kilopascals, an initial volume of 2 liters, and an initial temperature of 27 degrees Celsius. Later, the pressure changes to 120 kilopascals, and the temperature changes to 47 degrees Celsius. We are asked to find the new volume. Solution. Convert the temperatures to Kelvin. 27 degrees Celsius plus 273 gives 300 Kelvin. 47 degrees Celsius plus 273 gives 320 Kelvin. State the formula. P1 times V1 divided by T1 equals P2 times V2 divided by T2. Now substitute the values. 100 multiplied by 2 divided by 300 equals 120 multiplied by V2 divided by 320. 100 times 2 gives 200. 200 divided by 300 equals 0.667. So we now have 0.667 equals 120 times V2 divided by 320. Next, multiply 0.667 by 320. That gives approximately 213.44. Now we have 213.44 equals 120 times V2. Finally, divide 213.44 by 120. V2 is approximately 1.78 liters. So the final answer is 1.78 liters. Let's look at real-life situations. An aerosol spray can. When the can is heated, the temperature increases. As temperature increases, pressure inside the can also increases. If it becomes too hot, the pressure may become too high and the can burst. That is why we never expose spray cans to fire. Gay-Lussac's law, also known as the law of combining volumes. This law was proposed by a French scientist named Joseph-Louis Gay-Lussac. Let's dive in and explore this concept together. WAEC discovered something very important about gases. He found that when gases react, they do so in simple whole number ratios by volume, as long as the temperature and pressure remain constant. Now, let's make this easier to understand. Consider this chemical reaction. Methane gas reacts with oxygen gas to produce carbon dioxide and water vapor. In this reaction, 1 volume of methane reacts with 2 volumes of oxygen to produce 1 volume of carbon dioxide and 2 volumes of water vapor. So, the volume ratio of the product is 1:2 and the reactant is 1:2. Now, let's solve a quick question. What volume of oxygen is needed to burn 33 cubic centimeters of methane? From the equation, the ratio of methane to oxygen is 1:2. This means that for every 1 volume of methane, 2 volumes of oxygen are required. So, we multiply 33 by 2. This gives us 66 cubic centimeters. Therefore, 66 cubic centimeters of oxygen is required. Let's look at a real-life example. When you use a gas cooker at home, the cooking gas, also known as LPG, burns by reacting with oxygen in the air. During this process, the gases combine in fixed volume ratios. This proper ratio ensures that the gas burns efficiently, producing a steady flame for cooking. You've completed this lesson, well done. Now, let's go through a few quick questions to help us recall what we've learned so far. In today's lesson, we explain how the general gas equation helps us understand the relationship between pressure, volume, and temperature of a gas, when none of them is constant. We also learned about WAEC's law. WAEC discovered something very important about gases. He found that when gases react, they do so in simple whole number ratios by volume, as long as temperature and pressure remain constant. We hope the lesson was valuable and well understood. In our next class, we will study gas laws part 3. Thank you.